In a world increasingly threatened by drug-resistant infections, where illnesses such as COVID-19, RSV, norovirus, and the flu are already stretching the limits of public health systems, the idea of yet another layer of microbial resistance can sound overwhelming. Yet in the face of these mounting challenges, nature continues to surprise us with unexpected sources of hope. One such revelation is oyster blood, specifically the hemolymph of the Sydney rock oyster, which a new study published in PLOS One suggests could significantly strengthen our arsenal in the fight against drug-resistant superbugs. While this research is still in its early stages, its implications are strikingly positive and may signal a new era in how we address antibiotic resistance. The premise behind the study is both simple and profound. In their coastal environments, oysters are constantly exposed to a barrage of pathogens, bacteria, viruses, fungi, and parasites, without the benefit of a sophisticated immune system like humans possess. Lacking antibodies and adaptive immunity, oysters have evolved innate defenses that are remarkably effective at protecting them. Their survival, honed over millions of years, is built on the strength of their immune proteins, compounds that offer potent antimicrobial activity. Scientists have now isolated some of these proteins from oyster blood and found they not only attack harmful bacteria directly, but also supercharge the effects of standard antibiotics. The study's findings were compelling. In controlled lab settings, these oyster-derived proteins were combined with existing antibiotics and tested against bacteria that are known for their resistance and resilience. The result was a dramatic boost in antibiotic efficacy, up to 32 times in some cases. This means antibiotics that previously struggled to make a dent in infections caused by tough bacterial strains like Pseudomonas aeruginosa or Klebsiella pneumoniae suddenly became much more effective when paired with oyster proteins. This synergistic effect, where two treatments work better together than either one alone, could allow doctors to use lower doses of antibiotics, reducing side effects and slowing the development of resistance. What makes this discovery even more encouraging is its safety profile. The proteins extracted from oyster blood were found to be non-toxic to human cells, an essential first step in considering them for therapeutic use. That offers a key advantage over many experimental treatments that show promise in vitro but prove harmful when tested in the body. These oyster proteins appear not only potent but also biocompatible, clearing one of the biggest hurdles in pharmaceutical development. Even more exciting is the way these proteins function. Unlike traditional antibiotics, which bacteria have grown skilled at dodging, these proteins attack bacterial biofilms, the slimy, protective barriers that shield bacterial colonies from drugs and immune responses. By disrupting these biofilms, oyster proteins give antibiotics easier access to their targets, potentially restoring the effectiveness of medications that had become obsolete. In essence, they don't just fight bacteria, they dismantle the fortresses that bacteria hide behind. This approach also signals a welcome shift in the scientific community's mindset. Rather than simply trying to invent new antibiotics from the same templates, only to see bacteria outwit them again, researchers are increasingly turning to the natural world for inspiration. Oysters, whose immune systems rely entirely on innate mechanisms, offer an elegant model of microbial control that doesn't depend on one-size-fits-all chemical attacks. Their proteins strike in diverse ways, making it harder for bacteria to evolve resistance. It's a blueprint for durability and one that could be replicated or enhanced through biotechnology. Of course, we are still in the early stages of this journey. The leap from promising lab results to a real-world treatment involves years of further research, rigorous testing, and clinical trials. But the path is clear now. Scientists are already working on developing inhalable therapies for respiratory infections, injectable treatments to complement antibiotics, and even topical formulations for wounds and skin infections, all using oyster-derived peptides. It's not just a vision for the distant future, it's a direction already being pursued with confidence and optimism. This research also reinforces a broader truth. Some of the most powerful solutions to modern problems may lie in ancient and overlooked corners of the natural world. Oysters have thrived in microbial soup for eons, weathering conditions that would overwhelm most organisms. That resilience, encoded in their biology, may now offer a lifeline to human medicine at a moment of critical need. It's a testament to the untapped potential of marine life and a call to explore more deeply the immune strategies of Earth's most durable creatures. In the global fight against superbugs, a crisis increasingly described as one of the greatest health threats of the 21st century, this study provides not only new tools, but renewed hope. The prospect of amplifying our existing antibiotics with the biological wisdom of oysters is a vivid example of how scientific innovation, grounded in nature, can yield elegant and effective solutions. While no single breakthrough will solve antibiotic resistance overnight, research like this proves we are not out of options. The tide may be turning, and this time, it's the oyster leading the charge.